I'm going to ask you to do some by yourselves. I'm going to do some with you, but let's have a look and see. So the first question I have here, and I've made some choices of how I was going to lay this out. I'm not too sure why I've done this, but anyways, we're here now. Okay. Like I said, I don't know. I've made choices. They weren't very good choices, but they were choices nonetheless. Let's make better choices here. Okay, that makes more sense. No, sometimes I don't know what goes through my mind. Okay. So we have been given in the diagram, M is 3, -5, is the center of the circle having Pn as its diameter. KL is a tangent to the circle at N 7, -2. So just immediately what we should be thinking is, cool, we know where the center is. So we could go and work out the equation of the circle. We have a point on the circumference, which means that we can go and work out what the radius is, because even if I don't tell you how long the radius is, as long as you've got the center and a point on your circle, you're sorted. And we know we have a tangent. So we know that there is a point on the circle circumference where a line passes through once. So the first question says, calculate the coordinates of P. Okay, so if we have a look at where P is and what information we've been given about P, we were told in the question that the circle has Pn as its diameter. Stupid thing. So Pn is its diameter. What that means is that that purple line that I have so wonderfully highlighted there passes through our center. So Pm is a radius, Mn is a radius, and really importantly, that therefore means that it cuts the diameter in half. So M is the midpoint of the diameter because M is the center of our circle. So what that means is we can use our midpoint theorem to go and determine the coordinates of P. So remember, midpoint theorem says that, seems to be getting worse, and I'm trying not to cry. I am going to get it fixed. So midpoint, the formula says to us, x2 plus x1 over 2, y2 minus plus y1 over 2. So that's our midpoint formula. Now we know what the midpoint is. We know our midpoint is at 3, -5. The problem is we need to work out P's coordinates. So whatever the x coordinate of P is, plus the x coordinate of N, so 7 over 2, the y coordinate of P plus the y coordinate of N, which is -2 over 2. And I've said this to you guys before, what's so nice about this formula is the fact that it allows you to solve for 2 unknowns at the same time. So we know that this bracket of x plus 7 over 2, bracket, fraction, must be equal to 3 because those are both the x coordinates. And we know that this fraction of y minus 2 over 2 must be equal to -5. So this allows us, this formula allows us to work with these two values separately. So now I can say x plus 7 over 2 is equal to 3, and I can solve that equation. And then on the other side, I can say y minus 2 over 2 is equal to -5. And I can solve that equation. So I now have 2 very basic equations I can solve. So I would times both sides by 2, giving me x plus 7 equals 6. And so that therefore means that x is equal to -1. On the other side, solve for y, times both sides, y minus 2 is equal to -10, and so y is equal to -8. So you now have your coordinates of P. You don't really need to do much more than that. We now know P is at -1, -8. I would write that on my diagram just so that I have that information, but we now know where P is. Okay, so really nice about the midpoint formula grade 12s is you can separate it. You don't have to work with both of those fractions or both of those values at the same time. You can separate them and work with them individually. And that's why the midpoint formula is so, so great to work with. Okay, 4.2.1 says determine the equation of the circle in the form x minus a squared plus y minus b squared equals r squared. Now, we did quite a few examples like this. So I want you guys to give this one a try for me by yourselves. So you've been given the circle, you know a whole bunch of information about the circle. Read the information again if you're not too sure. And I want the equation in the center radius form. I'll give you like a minute or two and then we'll have a look. Remember, if you're not sure about something, just ask. Okay, let's have a look. So we had to find the center. Now, center of the equation, we automatically know where the center is. So we know it's x minus 3 squared plus y plus 5 squared. Remember, your signs are opposite. Problem is we don't know what r squared is. Okay, but try this for the third time. We've got points on the circumference. We've got P and we've got N. Now, it doesn't matter which point you substitute in to find r squared because they're both on the circle. I would advise you use the point that you were given. So I would substitute in point N. So N's x coordinate is 7. 7 minus 3 squared plus minus 2 plus 5 squared. And that will give you what r squared is. Just use your calculator. There is no point in trying to do it in your head. That gives you r squared is equal to 25. So now you know your radius is 5 units, but remember, we don't care about that. We care about what r squared is. So therefore, the equation of my circle is x minus 3 squared plus y plus 5 squared is equal to 25, because that's what r squared is. And that is what we need for the equation of our circle. Okay, so don't forget, even if you don't know the length of your radius, as long as you have got a point on the circumference of your circle, you can just substitute it in and you can get what your answer should be. Right, 4.2.2 says determine the equation of KL in the form y equals mx plus c. Now again, we did a lot of these. So remember, KL is the tangent to your circle. It's a straight line. And we know that your tangent is perpendicular to your radius. That's a really important piece of information here. So that's a little clue I'm going to give you. I want you guys to try question 4.2.2 for me. Work out the equation of KL in the form y equals mx plus c. And the hint there is remember that according to your tan chord theorem, tan radius theorem, your tangent is perpendicular to your radius. Hey guys, let's have a look. It looks like we're on the right track. Those of you who sent me messages, let's just double check what we've got going on. So we actually know nothing about the straight line except for one coordinate on it, which is not enough. But what we need to remember is that the gradient of your radius is perpendicular to the gradient of your tangent because of our tan perp rad theorem. Okay, so because of that fact, we can work out the gradient of our radius and we can then just use the perpendicular property. So the gradient of your radius is equal to, now remember it's y2 minus y1 over x2 minus x1. So minus 2 minus minus 8 over 7 minus 1. Chuck it into your calculator. There's no reason to do any more than that. That becomes 6 over 8, which is 3 over 4. Right, because of the relationship that they're perpendicular, remember what that means is that the product of those gradients equals -1. So if you were to take your radius gradient and times it by the gradient of your tangent, you will get -1. That is what it means to be a perpendicular line. And so because of that, we can work out what the gradient of our tangent is. So therefore, our tangent's gradient is -4/3. You just say -1 divided by the gradient you have. So we know y is equal to -4/3 x plus c. We still need to find our c value. I'm just going to carry on over here. We still need to find our c value, and this is now where we substitute in a point that we have. So we are going to substitute in our point n, which is at 7, -2. -2 is equal to -4/3, whoopsie, 4/3 times 7 minus c, and that gives you a c value of 22/3. Again, don't try and do LCVs and all the rest of it, just type things into your calculator. And so that means as our final answer here, we have got y is equal to -4/3x. There we go. Plus 22/3. Okay, and that is the equation of your straight line. So always just remember this really important theorem that we have. The fact that your tangent is perpendicular to your radius. That's a really important one. Okay. Right, so I think we're at a point where we're probably going to need to screenshot, otherwise things are going to get a bit small. So let's take a screenshot of what we have thus far, and then we'll have a look at 4.3. Although we actually probably could have gotten it all then. All right, so 4.3 says to us, for which values of k will y equals -4/x plus k be a secant to our circle? Okay, so let's establish what this actually means. Remember, why it's such a panic station for me here. A secant to a circle is where a line passes through your circle twice. Okay, what we have at this current moment in time is a tangent to our circle. I actually regret how I've drawn this line. Let's try this again. Okay, so things are not going as I had foreseen. Okay, so a secant to our circle cuts your circle in two places. What we currently have is a tangent to our circle. So we currently have a tangent to our circle, remember, at n 7, -2. And I'm talking about that specifically because if you look at this equation, that -4/3 is the gradient of your tangent. So basically, I'm asking you, how should I move this line, this tangent, up or down? Because k is your c value. So k is plus c. How should I move this line up or down in order for me to have 2 points of intersection? Oh, this is not going well. All right, so let's think about this. Excuse me. Having a problem. If we go back to our diagram, we can clearly see where our tangent is. And if we think of a line parallel to KL, that would also create a tangent that would be at this point or through the point P. All right, so that does not look very tangenty. Let's try and make it more tangenty. There we go. Okay, so what you can see is that this is parallel to the other tangent that we have, KL. And so essentially what that's telling me, I don't know why I'm trying to turn my chair. What that's telling me is that as long as my k value falls somewhere between those two tangents, my line, no matter where it is going to cut my circle twice. Those two tangents are the boundaries, are the outer limits of where my line can exist. Now, I already know what the c value of the straight line is. Remember, we've worked out that this is y is equal to -4/3. None of that was doing what I wanted it to do. Y is equal to -4/3x plus 22/3. So we already know that upper or one extreme of the tangent bounds. I now need to go and figure out what this tangent's C value would be so that I can figure out what range of K we can potentially have. Now, because those two tangents are parallel to each other, what that means is I already know that it's y is equal to -4/3x. I just need to figure out what the C value is. I know that it must pass through that point P because that's the point where the tangent will touch the circle. So I can just substitute in point P. And we've already worked out that P is at -1, -8. So if I substitute that in, -8 is equal to -4/3 minus 1 plus C. Again, just type it into your calculator. There's no reason for you to go and do anything more fancy. But that gives you a C value of -28/3. So what we have established, if I go back to this, I'm not going to go all the way back to the other diagram, but here's my circle in any case. Okay, so what we've established are the outer limits for C. So for this line, C was equal to 22/3. For this line, C was equal to -28/3. As long as it's between those two tangents, we will have a secant to our circle. Have a look at the blue line. No matter where I now draw it, as long as it falls between those tangents, it will cut my circle twice. So as long as it falls between that 22/3 and that -28/3, we're good. So K K must be less than the 22/3, but greater than the -28/3. It must fall in that range between my two tangents. As long as it is between the two tangents, anywhere along there, it will cut my circle twice and be a secant to the circle. Right, now that is definitely a more problem-solving, complex question. It's not supposed to be easy. But what I need you to remember is that on each end of your circle, and I say each end, it's a circle doesn't have an end. But if you think of tangents, if they are parallel to each other, no matter where they are bounding your circle. So anything in between there is then a secant to a circle. Anything beyond those tangents is then a line that doesn't intersect with your circle. So if this question had read something like, for which values of K will y equals -4/3x plus K not intersect with your circle, you would then know it would be greater than 22/3 or less than -28/3. Because anywhere more than that or beyond that, it doesn't touch your circle. Question, is leaving K in an inequality? Yes, it is. Sorry, I didn't actually finish the question, so let me finish the question. Is leaving K in the form of an inequality the final answer? Yes, because it says for which values of K, this is the range of values which K can be in order for us to have a secant to our circle. If it had said give one value or give a value, then you could just pick a value between that range, but it does say for which value, so we do need to give all options there. Right, the next question, what I want you guys to bear in mind is exactly what this says, is sometimes we give you points, but we don't show them on the diagram. We don't have to give you the points. So often, especially in like grade 10 and grade 11, when we were asking you to find the fourth vertex of a parallelogram, we would just give you a random point and then you'd call your teacher over and you'd be like, but there's no point X on here, or there's no point R on here. We don't have to give you the points on the diagram. Okay, I can give you a point that is not on your diagram and expect you to work with it. And this is what's happening here. So it says points A at TT and B are not shown on the diagram. From point A, another tangent is drawn to touch the circle with center M at B. Okay, now remember, the circle with center M. is the circle that we were given. And what I'm actually going to do is bring this diagram down for us so that we don't have to keep scrolling back and forth. Oh, good golly, Miss Molly. Yeah. So I haven't shown you points A and B, but I have said that from point A, another tangent is drawn to touch the circle with center M at B. So for example, what that might mean is that we've got point B over here. Yeah, we'll try that again. Now remember, B could be anywhere. I'm just making this up. So let's say, for example, B was here, point A was here. I'm joining that line or joining those 2 points so that I now have a tangent to my circle at B. That could be anywhere. B could be here, A could be here, and there's a tangent to your circle. Same thing here, A, B. It could be anywhere, but that is essentially what that statement is saying to us. So show that the length of tangent AB is given by square root 2t squared plus 4t plus 9. Okay, so now we have to go and get this expression here. I don't know why my brain has just decided to stop working for a second. We'll get there. Tangents. Okay. So remember, I just would like to draw this nicely for you guys so that I'm not causing absolute chaos. B. There is, let's just say, for example, A is there. So just remember that if you were to now go and construct a triangle, now there's a reason for this. I'm asking you for a length, but you have no information about the coordinates. Well, what you do potentially know is that you have a right angle triangle between your tangent to your circle, again, because of your tan perp rad theorem. Okay, so again, this is a slightly harder question. It's not supposed to be particularly easy, but it all relies on knowledge that you have. So between your tangent and your radius, you have a right angle, which means that if you join your center to that point A to the point where your tangent touches your circle, you actually have a right angle triangle. And what you then have is a right angle triangle that you can go ahead and work with. Okay, now you have got coordinates M. Obviously, I've now drawn over it, so that's on me. But you know that A is at TT. Yes, you don't know what the T value is, but you have a coordinate in terms of T. We can go and work out this length for AB using Pythagoras. So Pythagoras says to us that our hypotenuse squared, that would be AM squared. It's going to work with me at some point, guys. AM squared is equal to AB squared plus MB squared, or BM squared, whatever you want to say. We are looking for our tangent AB, which means that AB squared is equal to AM squared minus BM squared, or MB squared. Again, whatever your heart desires. So A to M, remember, is a distance. So you can go and use your distance formula. Okay, it's not supposed to be particularly nice. Right, so AM would be equal to, now remember your distance formula is equal to the square root of the differences. Your distance squared, which is what we're working with, you could just leave off the square root. So this would be equal to values T t minus 3 squared plus t plus 5 squared, because it's y1 minus y2 squared plus y1 minus y2 squared. So that's just am squared minus, now bm, remember, is this length over here. You already worked out way back in your first question, second question, that your radius was 5 units long. So because bm is a radius, you know that that's just minus 5 squared. Oh, this is going to give me 5 squared. And now we go and solve. We've got these brackets that we need to sort out, which is not the nicest thing in the world. I'm fully aware of the fact. You have to distribute, unfortunately, but it is what it is. So this would be t squared minus 6t plus 9 plus t squared plus 10t plus 25 minus 25, 5 squared. So we have got 2t squared minus 60 plus 10t is plus 4t. 9 plus 25 minus 25 is just plus 9. Now, if you have a look, what we have just worked out here is exactly the same expression that is underneath my square root. And that's great because remember, this is AB squared. We just want AB, so I would have to square root both sides, which means that I get square root of 2t squared plus 4t plus 9. And I'm able to show that that is in fact the length of AB. Right, so again, not an easy question, definitely a more complex problem solving type question. But what I need you to realize is that anytime you have a tangent to your circle, a line drawn from the center to the tangent is a right angle. And so we can create for ourselves a right angle triangle to allow us to do Pythagoras. Remembering then that the side length that you have drawn from center to radius, center to tangent is the radius. And as long as you then know the equation of your circle, you know that length. It's not something you need to go and calculate. If you needed to, you've obviously got your distance formula like we used here, and you can go ahead and do that. But you have that length. There is no need for you to go any further than that. All right, so we've shown that the length of AB is that beautiful thing. And then we have got 4.2.2, which says determine the minimum length of AB. Now, this takes us back to our quadratic equation knowledge. So remember, anytime, sorry, apparently I think throwing the pen is going to help the writing situation. Anytime we have a minimum or a maximum, and I'm just going to take a little tangent here when we are talking about quadratics. So a quadratic relates to a parabola. Okay, we're just going to pretend those are parabolas. Here you would have a maximum. Here you would have a minimum. What's really important is that at both points, that is your turning point of your parabola, whatever it may be. So we have got an expression here of 2t squared plus 4t plus 9. We have a quadratic. That's a quadratic expression, which means I can find the minimum or the maximum. Now, because it relates directly to your turning point, remember that the x-coordinate of your turning point can be found by saying minus b over 2a. And that's all we need to do. So we're going to say minus b, which is minus 4. Oh, okay, I'm just going to take everything off, apparently. So minus b, so minus 4. Over 2 of a, which is 2. I don't know why I said minus 4. Minus 4 over 2 times 2. 2 times a. And that gives me a value of negative 1. So what that's saying is that I have a minimum at x equals negative 1. Now remember, you're not solving for x here, you're solving for t. So that's t equals negative 1. And all you do, because you now know exactly where your minimum would be, is you substitute that back into your equation. So we know that the minimum length and the length, of AB was expressed by square root 2t squared plus 4t plus 9. You've just worked out where that minimum would be at. So you just substituted it. 2 times -1 squared plus 4 times -1 plus 9. And you chuck that into your calculator. And it tells you that the minimum length then of AB is root 7 units. Okay, now this concept of minimum and maximum, so this idea of a minimum and a maximum, comes up a lot in sequences and series as well. So particularly of quadratic number patterns, I might then ask you for what value of n would you find a maximum or minimum, or would the sequence reach a maximum or a minimum? Obviously, you find it a lot in functions. And then whenever you talk about lengths, so within functions, if let's say, for example, you have the distance between two graphs, as long as it's quadratic, you can use that concept to work out where the minimum or the maximum length between your graphs would be. The idea of minimum and maximum, very, very important from the quadratic base or the quadratic origins, but can be applied in other situations. So anytime you see something like that, just bear that in mind. Those of you that have done calculus, you could do this with the first derivative. That's obviously absolutely fine. We obviously haven't done it together yet, so I'm choosing not to do it. Honestly, I think first derivative and the turning point method are probably the easiest methods. I generally go turning point just because that's what I know. But if you have done calculus and you would have done this using the first derivative, absolutely fine. Nothing wrong with that at all. All right. So this 4 point, let's just make this a bit smaller so you can screenshot this. So this 4.4 is definitely the more complex problem-solving type of analytical question that you can expect. Often these questions deal with points not shown on your diagram, like here. Sometimes they deal with whether or not circles intersect with each other, whether a point lies inside or outside a circle, tangents, such as this question, is a line a tangent to a curve, and then questions based on that. But often there's a question that relies on points not on your diagram, and you then have to sort of work with an imaginary point and go from there. Okay, so just take screenshots of that so that at least you have those answers. And then let's have a look at another one. And remember, guys, analytical geometry is about 30% of your paper. So being comfortable with it is important. As you can see, it is generally question 4 and sometimes 5 of your paper. Question 1 and 2 stats. Question 3 is generally a grade 11 level analytical question, and then question 4, grade 12 with circles and tangents and all of those fun things. Then it moves on to trig and then Euclidean geometry. Okay, let's have a look at this question. So here we've been given a circle and a circle, which is awesome. And we have been told M -3,4 is the center of the large circle and a point on the small circle having O, 0, 0, it should say, as its center. As the center. Okay. From N, which is at -11p, a tangent is drawn to touch the large circle T with NT parallel to the y-axis. NM is a tangent to the smaller circle at M with MOS a diameter. So there's a fair amount of information that we've been given here. So let's just go through all of that to make sure that we are understanding what we've been given. Right, first things first, we were told that M is both the center of the big circle and on the circumference of the smaller circle. And we can see that NM is the tangent. Do that a bit better. Right, the second we're told tangent, we need to be thinking, cool, it's perpendicular to the radius. Tan perp rad theorem, we need to be thinking equations of that line. Do I know anything about it? What can I do with that? The next thing that we were told is the fact that we've got some parallel lines. We were told that NT is parallel to your y-axis. Okay, so again, parallel lines, think of your alternate co-interior corresponding angles. The final thing that we were told is that MOS is the diameter of your small circle. So those are all the bits of information that we have, and then obviously we've got coordinates there, and we can deal with that should we need to. So the first question says, determine the equation of the small circle. Alrighty, so we're not going to panic. First things first is we know where the center of the small circle is. We're told it's at the origin, so immediately I know I've got x squared plus y squared. I just need to figure out what the r squared value is. Now have a look there. You can very easily go and work out what your radius is, because you know that your radius is from O to M or O to S. It doesn't really matter. But you know that M is on the circumference, and you can just go and substitute in that coordinate exactly like we did in the last question. So we've got -3 squared plus 4 squared is equal to r squared. So 9 plus 16 equals r squared, which means r squared is equal to 25. So your radius is 5 units long. And so your equation of your circle, x squared plus y squared is equal to 25. Okay, nice and easy. Remember, the second your center has your circle has a center of the origin, it's just x squared plus y squared. Right, the next question says, determine the equation of the circle, sorry, I've got so many things in the way, centered at M in the center radius form. Okay, we can do that. That's not too tricky. We know where the center is. So we know we've got x plus 3 squared plus y minus 4 squared. And we need to go and figure out what r squared is. Have things moved here? No? Okay, sorry. I'm just... Apologies. Right. So we need to go and figure out what the radius is now, or what r squared is now. What we need to bear in mind is that we don't have any other point on our circle. Sorry, my brain. We don't have any other point on our circle. However, what we do know is that NT is a tangent to our circle. So we know that if we were to draw MT, that would be perpendicular to that tangent. Okay, hopefully we all agree with that. Now, if it's perpendicular to our tangent, what that means is, let's just get this right. This horizontal line, or this line from M to T, would be a horizontal line. Okay. The reason for that is NT is a vertical line because it's parallel to the y-axis. So all along that vertical line, the x values are the same. A line that is perpendicular to a vertical line has to be a horizontal line. So between M and T, that's a horizontal. What that means is you automatically know that the y-coordinate of T is 4. And because, like I say, NT is a vertical line, you also know that its x-coordinate is -11. So just by the nature of, or the characteristics of a perpendicular line, you actually know the coordinates of T. So we are going to substitute in those coordinates. So -11 plus 3 squared plus 4 minus 4 squared. Obviously, that's just 0. And that'll give us what r squared is. And so what that means is that r squared is equal to 64. And so now we can write down the equation of our large circle. So this is x plus 3 squared plus y minus 4 squared is equal to 64. So guys, what you're going to find, and particularly with analytical geometry, is that a lot of what goes on relies on just basic understanding. Again, I know that sounds silly, but perpendicular and vertical lines, or rather horizontal and vertical lines, is something you've been doing since grade 9. You've been doing it for 4 years. But because it's not something that we necessarily explicitly teach again and again and again, it's something that we forget. So all of those basics that you have been doing since grade 8, grade 9 are coming into these questions. It's the same as like geometry. We still expect you to know angles on a triangle. We still expect you to know exterior angle of a triangle, stuff that you did in grade 8 and grade 9. This is the same concept. You should know that a vertical line is perpendicular to a horizontal line. And because of that knowledge, you were able to go from there. Right, 4.3 says determine the equation of NM in the form y equals mx plus c. Okie dokes. NM is that orange line that we have there. We can't quite work out the gradient yet of that line, because we don't obviously know what P is, but we know that NM is a tangent to the smaller circle. So remember, we were told that NM is a tangent. If we can go and work out the gradient of OM, we can work out the gradient of our straight line NM. Okay, so quickly go and work out the gradient of OM for me. What is the gradient of your radius? Remember, the whole reason I'm doing this is because I know I've got a tan perp rad theorem going on there. Okay, close, just remember it's change in y. So it'd be, for example, 4 minus 0 over change in x, negative 3 minus 0. So that is negative 4 over 3. Okay, don't stress. It's often something that we get mixed up on. Just remember it's y in the numerator, x in the denominator. And so because of our tan perp rad, we know that the gradient of mn is 3 over 4. And remember, that's because the gradients product, so the product of your radius gradient times your tangent gradient will give you negative 1. So we know y is equal to 3 over 4x plus c. We substitute in a point that you know is on the line, so I'm going to substitute m. I don't know n's y value, so I have to substitute m. 4 equals 3 over 4 times negative 3 plus c. Again, do it on your calculator. No reason to try and be fancy. And we get that c is equal to 25 over 4. So y is equal to 3 over 4x plus 25 over 4 is our straight line. So again, guys, having that knowledge from geometry, bringing that in, as well as just prior knowledge from grade 8, grade 9, grade 10, grade 11, very important. And then particularly in the complex questions, think outside the box. And when I say outside the box, you have the knowledge. So some way you've been taught it, whether it's within the analytical geometry section, is up for debate. But for example, that maximum minimum question we had earlier, you have that knowledge. That's something that you've been taught before. Yes, within the context of functions, but you have been taught it. Okay, so let us, oops, it is, make the touch smaller. So 4.4 says calculate the value of Sn. I don't think I'm going to get to 4.5, but I will get to 4.4. So we want now the length of Sn. Now bear in mind, Sn is once again a line that I don't necessarily have to draw on here, but it is there. So it's that length between those coordinates. Okay, now you don't know S, you don't know the full coordinate of n, but you can work these things out. N is very easy to work out. You've just worked out the equation for the straight line. So you can go and substitute in the x value for n and find what the y value would be. So y would be equal to 3 over 4 times negative 11 plus 25 over 4. And you can go and get what n's y coordinate is. So the y coordinate of point n is at -2. So n's coordinates -11, -2. So you already have that. You need S though. Now remember, MOS was the diameter of the small circle. That means that the midpoint of the diameter is your origin. So much like we did in the first question, we can use our midpoint theorem to go and work out our missing coordinate. So we know that the midpoint is at 0, 0, and that was found by taking the x coordinate of S plus the x coordinate of M, so -3. X minus 3 over 2, and then same thing with y. Y of S plus y of M over 2. And now I can separate my fractions. So x minus 3 over 2 is equal to 0, and the y plus 4 over 2 is equal to 0. These are nice, easy equations to solve. X is equal to 3, y is equal to -4, so point S has those coordinates. And now that you know where point S is, you just use your distance formula and you go and work out what Sn is. So Sn is equal to the square root of, some great square root, let's try that again. The square root of, remember it's the x, the difference of the x's, so -11 minus 3 squared plus -2 plus 4 squared. And you just chuck that into your calculator. You don't need to do anything more than that. And that gives you 10 root 2. If you want to give it as a decimal, that would be 14.14. But there's no need for you to give it as a decimal if you don't want to. So in this question, just remember that even though you didn't know the coordinates, again, as I've already said, you have the information. Everything that you've done thus far is leading you up to the point where you can actually answer the question. All right, so let's take a screenshot of this. I don't know how small we're gonna have to make this. Yeah, that's pretty good. Remember, guys, today is quiz day. So you will see your quiz is uploaded on Google Classroom for you guys. Hopefully what you're seeing with analytical is that most of it is very straightforward. As you could see in the last question, sorry, I know I said take a screenshot, but as you could see in this question over here, it was 4.4 that was tricky. In this question here, it's 4.5 that's tricky. Majority of your questions are straightforward questions that you have all the information, all of the knowledge to go and answer. Okay, so take your screenshots, guys.